This video clip is on clouds and fog. We won't spend a great deal of time on clouds, as your book does a good job of explaining the cloud types, and most students have no problems understanding the material. I will give a brief summary, however. First of all, clouds are simply visible expressions of condensation. They can occur at any level in the sky. We classify clouds based on their form and their altitude. There's three forms of clouds: cirriform, stratiform, and cumuliform. Cirriform clouds are thin, wispy clouds, generally at high altitudes, and also generally made out of ice crystals, not water droplets. The name cirriform comes from the Latin for a lock of hair, which is implying, again, that kind of thin, wispy look to the clouds. Stratiform clouds are quite different. They tend to be lower altitude clouds, and they may cover the entire sky. They may not have a beginning or an end. And here the name stratiform comes from the Latin for spread out. We tend to get a lot of stratiform clouds here in the wintertime. Lastly, cumuliform clouds come from the Latin root that means pile, so you can think of accumulate. These are vertically oriented clouds. They may have a flat base at the lifting condensation level, but they can go up to great altitudes. These clouds can be common in the Midwest during thunderstorms, or anywhere that you have unstable air that is rising. Figure 614 from your book shows us the 10 different cloud types and what they look like. And it also shows us how we name clouds. Look here at the high altitude clouds, mainly cirrus clouds of some sort. You can get the thin, wispy look to them. Here's the true cirrus clouds. Cirrostratus are high altitude wispy clouds that tend to be a little bit more spread out, so we have the word stratus in there as well. Cirrocumulus clouds are like little tiny cotton balls way up high. The stratus clouds, by contrast, tend to be lower elevation clouds that are all spread out. If they're in little clumps, we might call them stratocumulus clouds, or if they're quite high, we use the term alto for altostratus clouds. Lastly, the cumulus clouds are the ones that are vertically oriented, again implying unstable air. One last term that we need to look at here is the term nimbus. We use the term nimbus for clouds that are producing rain. So a cumulonimbus cloud is a vertically oriented cloud that is currently producing rain, likely a thunderstorm in the case of cumulonimbus clouds. Nimbostratus clouds are stratus clouds that are producing rain. Generally, this rain tends to be more showery and less intense. Table 6.1 in your textbook lists the different cloud names and gives some explanation of where you might find them in terms of altitude and the characteristics of the clouds. So what do you think? What type of clouds do we have here? Hopefully you said cirrus clouds, these high altitude wispy clouds. How about here? These low altitude clouds that are covering the entire sky. This is classic stratus clouds. In fact, since it looks like it's raining here in the distance, we could probably call these nimbostratus. Next, how about these puffy clouds? Clearly some sort of cumulus cloud. And lastly, what about this? All right, this vertically oriented cloud, clearly a cumulus cloud. Since it's raining here, it's a cumulonimbus cloud. Check out this very distinct lifting condensation level. The warm air is rising, cooling as it expands. It reaches the dew point temperature here, cold enough to be at 100% relative humidity, and from that point on, The air is still rising, it's unstable, forming these big billowy clouds. Again, this is common in the interior of our country in the summertime. Next, let's consider fog. First, it's important to note that fog is essentially the same thing as a cloud. It's simply a cloud at ground level. The difference between fog and clouds is how each formed. Clouds form as air rises and cools adiabatically. We've covered this in great detail. Fog, however, rarely involves uplift, though sometimes it does. Most fog forms when the air at the surface is cooled to the dew point temperature, and or when enough moisture is added to air such that it becomes saturated. There are 4 types of fog based on how they form, and you should take notes and be able to list and describe each of these types of fog, as well as tell where you might expect to find it. First, a radiation fog. Radiation fog occurs when the ground radiates away heat, usually at nighttime, so that the air next to the ground then loses heat by conduction from the air to the cool ground. So what results is a cool layer of air that exists right at ground level. If that air cools below the dew point temperature, fog forms. Radiation fogs are common over surfaces that are good at absorbing and emitting radiation, such as dark, exposed soil. They are also more common in the wintertime, where you have cool nights. Next, an advection fog. Advection, you might remember, means a horizontal movement of air. Advection fogs occur when moist, warmer air moves horizontally over a cooler surface, either a cooler land surface or a cooler ocean surface. Advection fogs are common as air moves from the sea to the land, because remember, the ocean temperatures don't really cool down as much as the land does, so this warm, moist air coming over the land can create a coastal fog. Here in California, we have a cool current that runs from Alaska down the coastline of California. And in the summertime especially, when the warm, moist air from the ocean is pushed towards our coastline, we get a huge layer of fog as that moist air goes over that colder ocean current. So we get a huge layer of fog just offshore that gets blown onshore in the summertime. Next, upslope fog or orographic fog. This is when moist, warm air is forced up a mountain and it cools adiabatically. This is just like the orographic lifting that we noted for cloud formation. But if the clouds are close to the ground surface up here, we'd call them fog. So it's the same thing. Lastly, an evaporation fog. This occurs when water is added to cool air that is already nearly saturated. This is common over water bodies at night, as the warm water continues to evaporate and the cool nighttime temperatures tend to be lower than the dew point temperature. So again, we tend to find it over water bodies at night. So that's our 4 types of fog: radiation fog, advection fog, upslope or orographic fog, and evaporation fog. Notably, though, sometimes a fog may be a combination of more than one of these types. Let's look at a couple of California examples. California's Central Valley is well known for the Tule fog, this picture on the right. This white here is showing the whole Central Valley all fogged in. This famous Tule fog is a radiation fog that creates dangerous road conditions at night and early morning in the winter time. The air is rich with moisture from the rainy days in the winter, but then the ground cools off at night, and the air near the ground loses heat to the ground surface and cools to the dew point temperature, creating fog. Several of the largest car accidents in California, some with over 200 cars, have occurred in this Tule fog in the Central Valley. In the picture on the left, you likely recognize the Golden Gate Bridge. In the San Francisco Bay Area, our summer fogs are often advection fogs, created when the warm, moist ocean air offshore is blown towards our coast and encounters the cool current that runs along the coastline. This coastal fog belt is thick just offshore and is sometimes drawn inland when the Central Valley heats up, creating a localized low pressure and bringing breezes in from the coastal areas. Again, our summer coastal fogs are advection fogs. As geographers, we are interested in the spatial distribution of Earth features, like fog. Study the map here. In general, where do we find a higher number of fog days? What general locations receive very little fog? Can you predict what types of fog would be present in the locations shown below that commonly experience fog?